In this video, we will discover the key concepts covered in this course. Talk about AI agents seems to be everywhere these days. There is a growing realization that this technology could truly be revolutionary. An agent can be thought of as an LLM that can actually do stuff, that is actually take action. And of course, this has tremendous possibilities as well as tremendous risks. You can find, for instance, an article in the Washington Post dated 7th February 2025 titled, "I let ChatGPT's new agent manage my life. It spent $31 on a dozen eggs." The Azure AI Foundry Agent service, which only has recently entered general availability, is the Azure AI offering in this space. You will begin this course by understanding how agents combine an LLM, instructions, and tools, where the tools are invoked by the LLM to carry out actions. You will contextualize agents as the logical next step in the evolution of AI apps, coming after chatbots, LLMs, and assistants. Next, you will cover the features and capabilities of the Azure AI Foundry Agent service. You will enumerate the currently available tools, as well as the difference between basic and basic t-test, and standard projects, with the latter offering you the ability to bring your own resources. Finally, you will identify how the Azure Agent Service supports multi-agent workflows, and then how to pick between the use of connected agents within the Azure AI Foundry and semantic kernel and AutoGen for more complex multi-agent workflows. Agents and AI. After completing this video, you will be able to outline the evolution and capabilities of AI agents versus assistants. We are now fortunate enough to have reached a really interesting topic, and one which has a huge potential positive implications for the future, and that is the topic of agents and AI. Agents are AI systems that can perform tasks on behalf of humans, usually autonomously. Unlike bots, specifically chatbots, which can give advice, these can actually do things. Let's see what the world is saying about agents. These are all headlines from the Wall Street Journal, which is maybe the leading financial publication in the world. And all of these are headlines from the last couple of months, let's say from March through May 2025. AI agents are ready to take your call. Walmart is preparing to welcome its next customer, the AI shopping agent. Agents face one last big obstacle. Everyone's talking about AI agents. Barely anyone knows what they are. OpenAI wants businesses to build their own agents. Are really exciting. AI agents are everywhere and nowhere. Agents can do more than answer queries. That raises a few questions. And lastly, AI. Agents will transform customer relationships, for better or worse, for better or worse. Mind you, the Wall Street Journal is not even a technology-focused publication, so clearly agents are generating a lot of buzz. Now, let's talk about why you should care about agents. Well, to see the answer to that question, just see what agents can do. They can book flight tickets, they can reserve hotel rooms, they can schedule appointments, and pay your bills online. Clearly, any kind of technology that has all of these capabilities is worth paying attention to. Now, before we go any further, let me clarify right here that as of right now, Azure's agent service does not yet, as of late May 2025, have all of these abilities. There are, however, other agents out there in the marketplace that do know how to do these things, and I think it's very safe to say that Azure will focus. Adedzig needs something now, and soon she'll add functionality, just as soon as it is safe to do so. Now let's turn to agents from more of a technology perspective. We can think of an agent as an autonomous software component that perceives its environment, makes decisions. This is new. Chatbots don't do this. And finally, and most importantly, the agent can perform actions to achieve specific goals. So in terms of implementation, we can think of an agent as a composable unit powered by an LLM, equipped with tools to retrieve and use data, and governed by instructions that define its behavior and also define constraints. What are some defining characteristics of agents versus just chatbots? Well, these are autonomous systems that take decisions. That means that they need to actively interact with their surroundings. The main goal, again, is to make decisions based on input from the environment. And of course, this being the world of AI, those decisions are made adaptively. You hardly expect an agent to have a set of rules which it uses in Celode. Instead, it's learning from the environment and generating responses. This is a good point for us to talk a little bit about the evolution of AI. We can say that very early on, there were chatbots, which were keep computerized at Charger. These represented initial attempts at creating programs that could simulate human conversation and primarily relied on rule-based systems or on very simple pattern matching. Such chatbots were typically designed for specific tasks or domains, such as customer service FAQs. They had limited understanding of context or user intent. However, they did introduce the Waffle AI and laid the groundwork for LLMs, which came next. This, of course, was a turning point. LLMs represented a leap in natural language understanding and natural language generation. They enabled machines to understand, summarize, translate, and predict and generate human-like text with unprecedented fluency. Unlike earlier chatbots, LLMs can understand and remember context within a conversation. Of course, each step builds on the previous one, and so LLMs became integrated with chatbots in the form of ChatGPT. The chat in ChatGPT comes from chatbots, and the GPT refers to the LLM. The next stage in the evolution was that of AI assistants. These add functionality and integration process. Imagine AI assistants such as Siri, Alexa, Google Assistant, as well as ChatGPT and Gemini themselves. These build upon LLMs, and many of them can now do much more than just give advice. So assistants can set reminders, play music, provide weather updates, control smart home devices, and answer a wider range of queries by tapping into different data sources and APIs. Assistants take the first steps towards taking action, and AI agents take that much further. They operate more persistently, they learn from their interactions and their outcomes, and adapt their strategies over time with significantly less direct human prompting at each step. As a result, they have a much higher degree of autonomy. They are intended to have planning capabilities, including long-term planning capabilities, and the ability to interact with environments in more sophisticated ways. So, taken all together, agents are much more advanced than assistants. They can plan and manage a complex process with many steps. Assistants might use a few integrated tools, such as a calendar, but agents are meant to dynamically select, combine, and orchestrate a much broader array of tools. These might be APIs, databases, code interpreters, or even other AI models. And in this way, agents are meant to interact with much more diverse digital environments and in much more complex ways to gather information, take action, and overcome obstacles in order to meet their goals. And in this way, agents go above assistants as well as LLMs and decide what exactly needs to be done to accomplish a task. And once again, that might imply the execution of a complicated plan. All of this requires the ability to operate in an environment with much more ambiguity and also to constantly apply self-correction. Newer and newer agents are being designed every day to handle more ambiguous instructions and to exhibit rudimentary self-correction or replanning if an initial approach fails. Chatbots and assistants often fail and then come back asking for clarification about unclear inputs. Agents will try and infer intent, explore possibilities, and maybe ask a few clarifying questions or attempt alternative strategies, and in that way, they go significantly beyond anything that came before. Let's now try and put this understanding into a nice schematic diagram of how AI agents work. Let's break this down as usual. We start with the input. The input here comes in three forms: user messages, system events, and agent messages. User messages are direct requests, commands, or queries from the user. System events are automated triggers or notifications from other systems or from the environment, maybe a calendar reminder, a new email alert, or a sensor reading. And agent messages are internal messages or feedback from the agent itself, or from other agents, perhaps from previous steps or from parallel processes. Next comes the agent itself. It's of course, is the core of the system. It's responsible for processing the inputs and then depending on the actions to be taken. We can see here that this is three components: the LLM, instructions, and tools. The LLM is the brain of the agent, and it provides the natural language understanding, reasoning, as well as the planning and generation capabilities. The instructions are guiding principles, rules, or objectives given to the agent. They define the agent's purpose, constraints, personality, and how it should approach tasks. An instruction like, "You are a helpful assistant," or "always respond in a formal tone," or prioritize booking the cheapest flight, provided that it's either nonstop or only stops in JFK. Clearly, neither the LLM nor the instructions are unique to agents. What makes the agent special is the next component here, which is the set of tools. These are the external capabilities or resources that the agent can utilize to perform actions or to gather information beyond the LLM's inherent knowledge. The LLM will decide when and how to use such tools. This is what makes these tools different from RAGs. When the agent, that is the LLM, decides that it needs to access a tool, it makes a tool call. This itself has three parts: retrieval, actions, and memory. Involves sending an email, booking a calendar event, calling an API. Memory involves storing and recalling information from past interactions or from its own operating history. Memory allows the agent to maintain context, learn from its own mistakes, and perform multi-step tasks effectively. The simplest of these is retrieval. This involves actually accessing and fetching information from a knowledge base, a database, or from the internet in order to perform specific actions. And then there is the output of the agent. There are agent messages which could be natural language replies to the user, or internal status updates, or communications with other agents. And there is structured output, lowercase output. This is data formatted in a specific way for use by other systems or for clearer presentation. Notice that the output does not properly capture the power of the agent because it does not include the output of the actions. Hopefully, this has given us a good sense of what lies at the heart of an AI agent. There is a model that's going to be an LLM or a large language model. This provides natural language understanding, natural language generation, and adaptability, and in-context learning. Then there are the instructions, and finally, there are the tools. With this high-level context in mind, we can now turn to the Azure AI Agent service.